Hello, today what we'll do is determine if lines are parallel or perpendicular to one another based solely on their equations. So we're going to look at linear equations and determine whether lines are parallel or perpendicular. And we'll get into those definitions in a moment. So we're going to start as usual looking at what we need to remember from prior knowledge. So the title of the notes are Parallel and Perpendicular Lines. And in prior knowledge, what we'll need to remember is how to find the slope of a line only from its equation. And this can be done in a couple of ways. So the first way what we can do is look at if it is in slope-intercept form, which is y equals mx plus b, or if it is in standard form, this is called standard form, where you have the x term, the y term, then the equal sign, and the constant number. So you can find slope a fast way from each form of the equation. In slope-intercept form, the slope, of course, is the coefficient of x, or the number in front of the x. That's the slope. So if y is by itself, the slope is the number in front of the x. In standard form, you take the coefficient of x, put it over the coefficient of y, and then change the sign. So it's the opposite of the coefficient of x over the coefficient of y. And we'll see how that works in a few examples. So we'll need to recall how to find the slope of an equation, or the slope of the line given its equation. We also need to remember what the definition of the word opposite means in algebra speak. And opposite means simply change the sign. We need to remember the definition of reciprocal. And reciprocal is the inverse of a fraction, or simply to flip a fraction. So that's the reciprocal. And what we need to recall is the vocabulary putting those two words together, the opposite reciprocal of a number. So the inverse of a fraction, and then change the sign. That is the opposite reciprocal. So I'll do a few examples of opposite reciprocal. If we have the number 3 over 2, opposite reciprocal, flip it, change the sign, becomes negative because it was positive, and opposite means change the sign, so it was positive, it's now negative. Reciprocal means flip the fraction, so the opposite reciprocal of 3 over 2, negative 2 over 3. Another example, the opposite reciprocal of negative 1/3. Opposite means change the sign, so the number will become positive, and then we flip 1 over 3, we get 3 over 1, which is simply 3. So to start with negative 1/3, the opposite reciprocal, 3 over 1. We also have another example for the number 2, the opposite reciprocal of 2. Opposite would be, again, change the sign. And then when we flip 2, remember 2 is a fraction over 1. So when we flip 2 over 1, we get 1 over 2. So the opposite reciprocal of 2 is negative 1/2. So that is how opposite reciprocal works. Now we get into some previous definitions for vocabulary of parallel. So when you have parallel lines, you're dealing with 2 or more lines that will never ever cross. So in this example, I give a rectangle. And for this rectangle, we have side A, side B, side C, side D. So what we're looking at in this rectangle, we have a right angle here and a right angle here. Those are 90-degree angles. And so when I say parallel, I'm saying that side A and side C are parallel, meaning they will never cross. Side B and side D are also parallel. They will never cross. So parallel lines are lines that will never ever cross. They can look like this, they can look like this, they can look like this. Lines that never cross. That is parallel. We also need to remember perpendicular. Perpendicular means lines that cross at 90-degree angles, or right angles. Lines that cross at 90-degree angles. And that is what perpendicular means, and I'll emphasize that with that same rectangle example. So if we have a rectangle ABCD, and again that little square means it's 90-degree angle, A and D, see side A and side D, are perpendicular to one another. Side B and side C are also perpendicular to one another. They cross at right angles. So we have to remember the definition of parallel and the definition of perpendicular. With that, we can now get into notes. Okay, so what are the actual notes for this section? We start with parallel lines. So when we're dealing with parallel lines, again we're dealing with lines that never cross. They never cross. Parallel lines are lines that have the same slope. That is a note. Parallel lines are lines that have the same slope, the same rate of change. They will never cross. So when you're looking at equations, you're looking at two lines that have the same slope. So in this example, y equals 1/2 x plus 3 and y equals negative 1/2 x minus 4, both of these lines have a slope that are 1/2. They are parallel. So both lines follow slope-intercept form. Both lines have a slope of 1/2. Therefore, those lines are parallel. And I use this little shorthand to mean parallel. So it looks like this. That's that little shorthand, looks like parallel lines. So that's the note. Parallel lines are lines that have the same slope. Now, what about perpendicular lines? Perpendicular lines are lines that have slopes that are opposite reciprocal. So again, perpendicular lines, lines that cross at a 90-degree angle, have a slope that is opposite reciprocal. So here's an example. I have these two equations. Y equals 4x minus 7. Y equals 1/4 x plus 3. Both equations follow slope-intercept form. Both equations follow slope-intercept form. The first line has a slope of 4. The first line has a slope of 4. The second line has a slope of negative 1/4. First line has a slope of 4. Second line has a slope of negative 1/4. From the previous knowledge that I covered, we can remember that those are opposite reciprocals. The opposite reciprocal of 4 is negative 1/4. Flip it, change the sign. And the opposite reciprocal of negative 1/4, flip it, change the sign, is 4. Since the slopes are opposite reciprocals, these two equations are parallel. Or, excuse me, perpendicular. So if these two equations are perpendicular, we use the abbreviation of an upside down capital T to show perpendicular. Those are the notes. The rest of the lesson is going to be examples of telling whether or not equations are parallel, perpendicular, or neither. So the rest of the notes are determining if equations are parallel, perpendicular, or neither. And so we'll get into the first example. So in the first example, we're going to have two equations. Y equals 2x plus 3 and negative 2x plus y equals 5. So we're going to have two equations. And our goal is to determine if these lines are parallel, perpendicular, or neither. And then what we have to do is explain our answer. So what we have to do is find the slope of each of these lines. Find the slope of this line, find the slope of that line. So for the first line, finding the slope is easy. it follows y equals mx plus b format. This equation is already in slope-intercept form. And since slope is the coefficient of x, the slope of this line is 2. So it's so easy to see that the slope of the first line is 2. All we have to do now is find the slope of the second line. And the slope of the second line, we can do this a few ways. We can solve for y, just like we've done in the past, or we can recall that there is a shortcut. This equation is in what's called standard form, where we have the x term first, the y term second, and then the constant. And to find slope from standard form, this is going to be kind of a neat shortcut. The slope is the opposite of a over b. The slope is the opposite of this coefficient over this coefficient. So what we have to do is look for the coefficients. In this example, the coefficient of x is -2. So for slope, we have the opposite of -2 over the coefficient for y. So what's the number in front of the y? A 1. So the slope of this line is -2 over 1, which when we simplify that becomes positive. So the slope of this line, +2. Now, we have found the slope of the first line, we have found the slope of the second line. The question again is, are these lines parallel, perpendicular, or neither? So we compare the two slopes. Slope of 2, slope of 2. They have the same slopes. And from the notes, we know that if they have the same slope, they are parallel lines. And so we can argue that these two equations are parallel because they have the same slope of 2. This equation, parallel to this equation, slope of 2. Let's do another example. So in another example, we'll have two more equations. -3x minus 4y equals 6, and y equals 4/3 x minus 1. And so we have these two equations, and the question remains the same. Are these lines parallel, perpendicular, or neither? So what we have to do is compare the slopes. In the first equation, we can still solve for y, just like we did for graphing, put it in a slope-intercept form, or we can use our shortcut. If we have the x term, then the y term, then the constant, the slope is the opposite of a over b. So in the case of this equation, we have the opposite of, the coefficient for x is -3 over the coefficient for y, which is -4. And when we simplify this, a negative over a negative is a positive, but then there's that negative out in the front. So this will still remain a -3/4. That is the slope. So the slope of the first line is -3/4. Now we have to find the slope of the second line. So we look at the second equation, and we can see very easily this is in slope-intercept form. And so simply to identify the slope, it's the coefficient of x. And in this case, the slope is 4/3. Now that we have identified the two slopes, the slope of this equation, -3/4, the slope of this equation, 4/3, are they parallel, perpendicular, or neither? They're obviously not parallel, they're not the same. Are they opposite reciprocals of one another? So if I take -3/4, change the sign, and then flip the fraction, will I get 4/3? Absolutely. So these are opposite reciprocal slopes. Opposite reciprocal slopes. And I'm still working on spelling. Therefore, these two lines are perpendicular. Remember, the goal was to determine, are these two lines parallel, perpendicular, or neither? Let's do another example. We'll have 2 more examples. 3 more examples. So the next example, I'll give you 2 more equations. We'll start with y equals negative 1/5 x plus 3 and 2x minus 10y equals 3. So we have these 2 equations. The question is still, are these 2 lines parallel, perpendicular, or neither? So we have to find the slope of each line. The first equation follows the format y equals mx plus b. Very easy to see that the slope in the first equation is negative 1/5. Using our newly found shortcut for the second equation, we can still solve for y. But using the shortcut, we know that this is in standard form, and the slope is the opposite of a over b. So in this case, it's going to be the opposite of 2 over negative 10. So in the second case, the opposite of 2 over negative 10. So the first thing we have to realize is that a negative over a negative is going to be positive. So we can already say that because we have the 2 negatives here, we're going to deal with a positive 2 over 10. And then we can simplify 2 over 10 to 1 over 5. So the slope of that second equation is 1 over 5. And so now the question is, are these lines parallel, perpendicular, or neither? In this case, the slope was negative 1/5. In this case, the slope was positive 1/5. So they're not the same. This one's negative, this one's positive. They're not equal, so they can't be parallel. Are they opposite reciprocals? Now, this one's negative, this one's positive. Yes, they are opposite, but they are not reciprocals. If I flip this one, I get positive 5. If I flip this one, I get negative 5. And they're not reciprocals. So yes, they're opposite, but they are not reciprocals. These are neither. This is neither parallel nor perpendicular. Even though they are opposites, they are not reciprocal. So they're neither parallel nor perpendicular. They just cross. They just have 2 different slopes. Slope of 1/5, slope of negative 1/5. They look like this. That's not parallel, that's not perpendicular. So again, the goal of this lesson, determine if lines are parallel, perpendicular, or neither. Let's do 2 more examples involving my favorite types of lines. Here's an example. X equals 7, y equals 7. Are these lines parallel, perpendicular, or neither? Now, if you're looking at that they both equal 7, you might think, hey, those are the same, it's parallel. But let's think. In the first equation, x equals 7, there's no y. And if there's no y intercept, meaning that this is a vertical line. Vertical line. Remember, vertical line looks like this. Vertical line. In the second example, y equals 7, there's no x. And if there is no x, there is no x-intercept. And if there's no x-intercept, this is a horizontal line. And if you remember, a horizontal line looks like this. So the question is, are these two lines parallel, perpendicular, or neither? So the first one is vertical, the second one, horizontal. That is perpendicular. So this is completely perpendicular because you should know that vertical is perpendicular to horizontal. That is a good little trick to know. So these two lines are indeed perpendicular. So don't be fooled by the fact that they both equal 7. This one is vertical, this one's horizontal. Now we'll do one more example to keep you on your toes. Last example of two equations, whether or not they are parallel, perpendicular, or neither. If we have y equals 3 and y equals negative 1/3, are these two lines parallel, perpendicular, or neither? Your gut reaction might be to say, well, if I have a 3 and a negative 1/3, they are opposite reciprocals of one another, therefore perpendicular. Wait, don't jump to that conclusion yet. Look at the equation. This equation is y equals 3. There is no x. And if there's no x-intercept, which means it is horizontal. And the same thing with the second equation. There is no x. And if there's no x-intercept, meaning this equation is also horizontal. So these are two horizontal lines. Horizontal line, horizontal line. They are parallel. That is indeed the definition of parallel. So these are both horizontal. They are parallel lines. So for the lesson, determining whether lines are parallel, perpendicular, or neither, we look to finding slope. Thank you very much. Good luck.